Hello and welcome everyone. My name is Rahul Das and today I'll be presenting my synthesis report which I have been working over past few months. So today in this presentation we'll explore how two powerful forces, that is factory style automation and also the integrated digital project management, are combining to transform construction. So on the left you see a highly automated fabrication shop, and on the right title of our talk, over the next 17 minutes I'll show you how robots, CNC machines, AI and digital models can cut schedules, improve quality and also reduce waste, and how these advanced pair with techniques like BIM driven coordination and also risk tracking to keep mega projects on time and on a budget. So let's begin by zooming out the industry's biggest challenge. So moving on to the abstract. So this slide sums up our journey. In the top left, we list the industry challenge, that is the inefficiencies, also the cost overruns, the delays, the labor shortage, safety risks, and also the sustainability gaps. The top right, our four key transformation drivers, that is advanced automation in the US modular fabrication and also the sophisticated project management on large infrastructure work. Bottom left shows our research focus, examining leaders like Autovol, VVC, Factory OS, and Z Modular plus insights from AECOM, that is Kausal Kumar on San Francisco, who is working on Central Subway project. Bottom right highlights significant impact will prove up to 50% faster schedules and 40% cost savings, and also the better precision and massive waste reductions. This roadmap will guide us through the slides and also ahead. Here we set the stage. On the left, under industry pressure, you see the global instruction must deliver more infrastructures and housing. Yet it faces the proactive timelines, budget overruns, and also the aging workforce, safety concerns, and environmental impacts from the wasted materials and the energy. On the top right, there is a transformative trends which shows that they are the converging. First, industrialized offsite fabrication, modular construction factories. Second, the digital project management, which is the BIM, RIX register, and also the integrated communication. So this talks the synthesizes both trends to give you a complete picture of how we can meet growing demands more efficiently, that is predictably, and also meeting the sustainability goals. Here we have the background, that is how was the modular construction and what was the evolution of the modular construction. So in this graphic, a conveyor belt shows that the modules moving through four stages. On the right, we have the historical roots, which reminds us the prefabrication has long existed, but today, factory production goes far beyond the simple panels to fully finished volumetric unit offsite. We have here automated automation integration, which marks the next leap. Industrial robots such as CNC machinings, AI, and digital twins align with modular construction with high volume manufacturing. Last but not the least, we have a market growth which reflects the rapid adoption of AI, robotics, and also the design for manufacturer and assembly, which is a DFMA principles. So this evolution shows why module is no longer a niche. It's become a mainstream response to industry inefficiencies. So here we can see the infrastructure project complexities. This slide breaks down 5 key challenges in a project like the Central Subway. First is geotechnical complexity management, which shows how slurry TBMS and a real-time soil monitoring handle San Francisco's tricky ground. Second is intensive stakeholder coordination, which highlights the need for robust risk frameworks and also the clear communication with funding bodies, city, agencies, business, residents, and also the advocacy group. Next, we have the design for resilience, which speaks to strict seismic standards. Then we have proactive sustainability integration, which reminds us that the energy efficiency, recycled materials, and public art elements were planned from day one. Finally, there is a leveraging digital technology, which uses a BIM as a digital twin for clash detection and also a workflow optimization, which was essential to keep the projects on track. Moving on to how this research was carried out. So I had four prongs. That is, a first literature review, which scanned the industry reports, academic papers, company publications, and news articles to map existing knowledge. Second, I did expert perspective synthesis, which incorporated detailed insights from my interview with Kaushal Kumar, who works for the Salkrit Corporation on the Central Subway. Third I did was the data analysis and the comparison blended qualitatively interview themes with quantitative factory metrics, cycle times, cost savings, waste audits to sport patterns. Fourth was the cross validations, which ensured the findings held up by the checking factory claim against the real world project outcomes. This multi pronged method gives us the confidence that our conclusions apply both in the shop and on the job sites. So the interview insights with Kausar Kumar experience offers us four lessons, which is the project complexity, navigating a $1.6 billion tunnel under dense urban streets demanded rigorous technical standards. Next is stakeholder management, which transparent the meetings and responsive communications with funding agencies such as business, residents, and advocacy groups to keep support. Next is we have digital tools, which is the BIM served as the project tools such as digital backbones, central for planning, simulation, coordination, and execution. We have risk management, which robots the framework for identifying, accessing, and mitigating risks, especially for unexpected soil and community impacts, were critical. So his insights showed that the strong process and people management are vital as cutting edge technology for construction. So here in this slide, we'll see the top leading automated modular factories. So this table profiles four US leaders in the automated modular, which is the first is the Autovol in Idaho, which focuses on the wood frame apartments powered by ABB robots and the digital twin workflow. Next, we have a VVC which has a diversified oats and a steel line with a varied automation levels and a DFMA emphasis. We have again Factory OS in California, which targets the affordable housing and runs a UC Berkeley innovation. That is a Lab G modular part of Jackelman Industries, which builds the steel modules using the proprietary G block connection. Each uses the automation differently, but all aim to scale construction like a factory. So in this slide, we'll see the key technologies in automated construction. So in this donut chart and list, so there are five technologies which stand out. First is robotics handle, which frames weldings and materials transport for speeds, precision, and safety. Next is CNC machining, which automates the high precision cuts to ensure tight tolerance and minimize waste. We have AI and machine vision, which automates the quality control, detects defects, and enable predictive maintenance. We have digital twins and BIM, which creates a virtual prototypes for clash detections, assembly simulations, and also offline automation programming. Then we have integrated software platforms which tie CAD, MES, ERP, and shop floor systems into a seamless digital thread for real time data and coordination. So, together, these tools transfer modular shops into a smart factories. Moving on to the next slide. So, here we can see the accelerated timelines and also the enhanced quality. So, going on to this slide, we see the headline metrics, that is 50% schedule reduction, parallel work in factories, and on site compressed total timelines. Also, 40% cost savings, which fewer labor hours, less waste, and minimal rework driven through expenses. And we have 90% waste reduction, which precise factory environments and recycling programs slash scraps. The infographic on the right contrasts a traditional timeline, long start year prone with a smooth modular process. So this gain shows how automation and tight process controls deliver both speed and quality, turning construction from an art at a risk of delays into a reliable factory style production. So here in this slide, we can see the some of the challenges, which are the capital investment and also the integration. So this pyramid shows the four major hurdles, which are the at top risk is the high capital investment. That is the setting up the automation hardware, software, and specialized facilities, which requires tens to hundreds of millions of dollars. Next is technology integration complexity. So here is different machines and the software often don't communicate. So IT team spends months or years building custom links. Next, we have operational demand, which factories need skilled technicians and strict maintenance protocols to avoid costly downtowns. So at the base, but which is the last but not the least, which is the design paradigm shift, which shows that project must adopt the design, manufacture and assembly, which is DFMA principles from day one, and changing how architects and engineer works. So overcoming these challenges take careful planning, strong leadership, and deep pockets. So here in this slide, we'll see the workforce adaptation and also the external factors. So this slide lists four external challenges, which the first is the workforce skill gaps, which highlights the needs to retrain traditional trades people for automation roles. Then we have regulatory hurdles, which points out that many buildings codes and permits don't yet fully support the volumetric modules. Then we have logistic challenges, obviously, in the modular construction, that is very obvious, which refers to the difficulty of transporting challenge, which finishes the modules through the city streets, which requires spatial scots and route planning. Last but not the least, we have market fluctuations, which reminds us that economic slowdowns or internet rate changes can reduce factory orders, leaving expensive equipments underutilized. So, addressing these factors means investing in education, updating regulations, and planning flexible manufacturing strategies. Now, looking at to the future trends for modularization. So, looking ahead, we have first is advanced AI integration, which will let machines self-optimize processes in real time using adaptive robotics, quality control algorithms, and predictive maintenance to minimize the downtimes. So now we have also the enhanced digital twins, which will become fully data connected model spannings and asset entire life cycles, which designs the construction, operation, and maintenance, allowing the owners and the stakeholders to monitor the performance and the plan upgrades virtually. Then we have the connect factories, which enable the software defined automation lines that reconfigure automatically for new products. Last, we have the data driven optimization, which will leverage analytics across the supply chain to continually improve the efficiency, cost, and sustainability on every project. So, together, these trends promise to make construction more intelligent and agile. So, here in this slide, we'll focus on the future trends that prioritize the sustainability and human machine collaboration in modular construction. So, first, we have a circular economy focus, which shows the designing buildings for easy disassembly, reuse components, and low carbon materials that withstand the climate and seismic risk. Then we have the optimized human machine collaboration, which lets the robots handle heavy repetitive tasks such as the welding, lifting, and also the material supports, while human focuses on complex plannings, quality, oversights, and community engagements. Then finally, we have a growing emphasis that is a community value and equity, which ensures a project deliver affordable housings and public amenities, aligning construction outcomes with local needs. So this human-centered sustainable approach strengthens the community trust and makes technology advance more socially responsible. So moving on to the next slide, that is the experimental analysis which modular fabrication performance. So this bar chart compares the traditional construction, which dark purple with automated modulars and light purple across four metrics. So here is the project timeline is cut from the roughly 50 weeks to 25 weeks, half the time. The labor hours which drops from the about 45,000 to 30,000, which shows the 33% of labor reduction. Then we have a material waste which can shows that 18% to under 2%, which demonstrating the up to 90% of waste reductions. Last but not the least, we have a quality defects, which shows the per 1000 units shrink from 12 down to 3. So that is a 75% improvements. So this experimental results confirm that modular automation delivers major real world benefits on speed, cost, waste, and quality over traditional methods. So moving on to the results, that is also the synthesis of the key findings of this project. So this slide distills our key takeaways into four themes. That is technology convergence, which shows that modular fabrications and major infrastructure projects rely on the same digital backbone. That is the BIM and digital twins, offering the integrated solutions. Then we have a improvements, which shows that a quantifiable up to 50% faster schedules, 40% cost savings, 90% waste reductions, and a better safety. Then we have a implementation barriers, which includes a high capital cost, workforce upskilling, integration complexity, and the need for DFMA mindsets. Finally, we have a future directions, that is points towards deeper AI use and futurely fully connected digital twins, that is the software defined factories, strong sustainability, resilience, and human machine teamworks. Now here you can see we have the integrated framework. So first a digital foundation, which once shared a BIM digital twin that connects a off-site factory optimization with on-site coordination, enabling virtual planning and class detection. Second, we have manufacturing principles, applying lean process optimization, rigorous quality control, and automation to construction as if it were a factory. Then third, we have advanced project management, which using a structured risk management, stakeholder dashboards, and embedded sustainability and a resilience goal. Then we have this three pillar model, which provides a repeatable recipe, which for delivering a faster, better, safer, and a greener building projects. So to conclude this presentation, the US construction industry is at a turning point. Automated modular fabrication delivers a dramatic gain in speed, cost, waste reductions, and also the quality. Integrated digital projects management ensures the complex infrastructure project stay on track and in budget. But to fully realize this potential, we must overcome the capitals, skills integration, design, and regulatory challenge. So by investing in this training, updating codes for modular methods, adopting open data standards, fostering collaborations among designers, fabricators, and owners, we can bring a smarter, greener, safer, and more equitable communities. Thank you, and I'm happy to take all of your questions. And you can email me for any queries at dasr2 at the rate unlv at the rate nevada.edu.